Hello, everyone, and welcome to Trigonometry Sine and Cosine Law lesson number 3. So far this unit, we've done a review of right angle trigonometry, and we've learned about the sine law. Today, we're going to learn about the cosine law. And in this 1/8 model, if we're still going with this 1/8 model, this is the last lesson we're going to do in this unit. So let's get started. The first part here says is an introduction, and it says, look at this triangle right here. Angle A is 36 degrees. The side AB is 3 centimeters, and the side AC is 6 centimeters. So using our new labeling notation, angle A is here, so that means side A is, little a is there. Angle B is here, that means 6 centimeters is side little b. And capital C is on the far side, so that means little c is 3 centimeters. What happens when you try to apply the sine law to determine the length of BC, which is side A? Well, we are looking for A, and we know angle A, which is 36. We know B is 6 centimeters, but we don't know angle B. And we know C is 3 centimeters, but we don't know angle C. So you can, if you look at this formula, you can see that in all of these ratios, we only know one piece of information. So we actually can't do any calculations on that. So the sine law doesn't apply to this triangle based off of the information that we have. And the information we have is called it's a side angle side, because if you look at this triangle, we know a side length and another side length, and we know the angle between the two sides. So it's a side angle side triangle where we know two side lengths and the angle nestled between those two side lengths. And when that happens, when we know the length of two sides and the contained angle between those sides, the sine law doesn't work. So let's skip over this first bit like we normally do, and let's jump right into what is the sine law. Sorry, the cosine law. What is the cosine law? I'm not going to show you the proof, so you just have to trust me that this works. If you are sitting at home and you're thinking, this doesn't work, this can't be right, come see me, we'll go over the proof together. So the sine law states that if you're looking for side A, we can write it as a squared is equal to b squared plus c squared minus 2 times b times c multiplied by the cosine of A. That seems really complicated, but you don't need to memorize this. You just need to know how to use it. So it's like a modified Pythagorean theorem type formula. And it doesn't only work for a squared. If you're looking for side B, it would be b squared is equal to a squared plus c squared minus 2ac times the cosine of b. So you can see that if we're looking for side length b, then at the end, the angle is always going to be b, and the other two sides that we're using to calculate are the opposite, or the other two than the one we're looking for. I know that's really weird, but it'll help you memorize. So if you're looking for side length c, then we know that the first two are going to be the remaining sides, b squared plus a squared. And then we're going to subtract 2ba or ab, doesn't matter, ba. And then we're going to multiply by cos of the angle that we started, of the side we started with, so cos of c. So let's actually look at using that. There's a proof here. If you really want to see it, come talk to me. I'll show you. We'll go over it. But I really want you to make sure you know how to use it. Here are the other two forms of the equation that we just also wrote up there. But if you want a nice, neat version, it's in your book. So here we go. This is the triangle we started with in the introduction. We know we have side little b and side little c, and it wants us to determine the length of BC, which is the length here between B and C, and we know it's across from angle A, so it's actually side A, little a. So we are, oh, I just touched a bunch of things on my keyboard. We are looking for side A, so our cosine law is going to be a squared is equal to b squared plus c squared minus 2bc cos of A. And this cosine law works because this triangle is an SAS triangle. So we have two sides and the angle that's nestled between. So let's fill out what we know. B is 6, so we have 6 squared plus C is 3, so that's 3 squared minus 2 multiplied by 6 multiplied by 3 multiplied by the cosine of angle A is 36 degrees. So you can actually just type all of this into your calculator. Or if you'd like, you can solve it, right? 6 squared is 36 plus 3 squared is 9, so, and then do all the rest of it. But you end up with 15.87, and so on and so forth. And then if we want to solve for that, we can do, that's weird. We can square root A because we don't want to find a squared, we want to find a, and a comes out to be 4.0 centimeters. They want it rounded to the nearest tenth, and it rounds up to 4 centimeters. So this one's not so bad. It's honestly just making sure you put in the right values in the right spots and calculate correctly. So next example, consider triangle PQR shown below. Complete the cosine law for calculating the side Q. First thing I'm going to do is label my sides. Little q, little p, little r. For calculating q squared, it's going to be p squared plus r squared minus 2pr cos of q. So it says here, calculate to the nearest tenth of a centimeter the length of the third side of triangle PQR if QP is 1.7, so that side is 1.7. QR, which is little p, is 3.1, and angle PQR, which is angle Q, is 110 degrees. So we're going to use, so we're solving for the third side, which is the side we don't know, and that's little q. We've already written down the cosine law for that. I know I'm going to use cosine law because I have two sides of a triangle. I know those two sides, and I know the angle nestled in between. So now I can just fill in what I know. Q squared is equal to p squared, which is 3.1 squared, plus r squared, which is 1.7 squared, minus 2 multiplied by p multiplied by r multiplied by the cosine of 110 degrees. Type all of that into our calculator, and we get q squared is equal to 16.104, so on and so forth. I can solve for q by square rooting both sides, and I get q is equal to 4.0 centimeters. Again, that's weird. Both of them are 4. Oh, hopefully this is making sense. Let's do one more example for good measure. Bellevue is 30 kilometers north of Air, and Churchville is 18 kilometers northwest of Air. Okay, this is fun. So we're just going to mark Air on our map, and we know that Bellevue is 30 kilometers north. This is Bellevue. And Churchville is 18 kilometers northwest. So first of all, never eat shredded wheat. It looks like northwest is going to be this way. So Churchville is 18 kilometers that way. Calculate the distance between Bellevue and Churchville. This is a trick question. All right, I see what they're doing here. Sorry, I'm just touching buttons now. So they want us to find this side right here. The problem is we have these two side lengths, which is great, but we don't know the angle between them. So what I want to do is first look at a compass. So if this is our compass, never eat shredded wheat, we know that the angle between north and east is 45 degrees. The angle between south and west is 45 degrees. So basically, the angle between the cardinal directions, N, S, and W, is 90 degrees. But if we are moving it directly northwest, my drawing on this computer is kind of tricky. What is going to be this angle right here? Well, it looks like it's halfway between north and west. So what's half of 90? Half of 90 is 45 degrees. So anytime we're moving at from north to northwest, or for example, west to southwest, that's going to be 45 degrees. So that tells us that is 45 degrees. We needed to know that angle in order to do our cosine law. So we can label this triangle if we want. We can say that we're looking for side A, this is side B, this is side C, and that makes this angle A for air. So I'm looking for A, so it's A squared is equal to B squared plus C squared minus 2BC, sorry. 2BC cos of A. So now we can fill out what we know. 30 squared plus 18 squared minus 2 multiplied by 30 multiplied by 18 times cos of 45. We can type all of that into our calculator and we get A squared is equal to 460.32, and we want to solve for A, not A squared, so we can square root both sides, and we get the distance between Churchville and Bellevue being 21.45. They want it to the nearest kilometer, so 21 kilometers. Yay, we did it. That was a bit of a longer video. Oh, we're not done. Sorry, quickly. There's an alternative form to the cosine law. So you can actually use some algebra to rearrange this. If you know all three sides and you want to find the angle instead, you can rearrange this to be in this form right here. Cos of A is equal to B squared plus C squared minus A squared divided by 2BC. So if you have the triangle SSS, or you know all sides of the triangle, then you can also solve for that. So I will go over one more example. So here, if we're looking for angle B, we know that it's going to be the formula is going to be C squared plus A squared minus B squared all over 2CA. And if it's cos of C, it's going to be A squared plus B squared minus C squared all over 2AB. Wait, where did I go wrong there? Something's not right. And what did I do wrong? Oh, I think the book is wrong. My answer key is wrong. Dang, I think I'm right. Take that, AVP Publishing. Just kidding. This is a great book. Okay, sorry about that. Had a little blip in my brain there. Okay, let's do one quick example. Determine the largest angle in triangle ABC. So let's just make a triangle. Determine the largest angle if side A is 14.7, B is 8.9, and C is 12.6. That was terrible. So determine the largest angle. Well, the largest angle is going to be across from the largest side, which makes sense, right? The largest side is creating the largest angle, so that means this is our largest side, which means this is our largest angle, which is angle capital A. So we can use our formula. Cos of A is equal to B squared plus C squared minus A squared over 2BC. And we can just fill in what we know. B squared is 8.9 squared plus 12.6 squared minus 14.7 squared, all divided by 2 multiplied by B multiplied by C. And if we type that into our calculator, we get 0.0975. And then obviously, if we're looking for an angle, we want to use our inverse function. And that means we get angle A equaling 84 degrees. So that is the cosine law. It's just an alternative form of the formula based off of what you're looking for. All right, now I can say thanks for watching, and I will talk to you